Hello there. This is our second class on the chapter sets. Um, Sorry for the late upload, just because we were having some connectivity issues. Now, before we begin, let me just do a small recap of whatever we have done in the first class. In the first class, we have talked about the definition and representation of a set. What is a set? Set is a well-defined collection of objects. And representation, obviously, we have learned that there are two ways of representing a set. One is called the roster form, the other one is called the set builder form. Then we talked about the different types of sets, obviously finite, infinite, empty, non-empty, and obviously singleton. Now then we discussed about equality of sets. Now this is one of that topic many of you had problem with. I don't know why. It is pretty simple to understand. Two sets are said to be equal if the number of elements are equal as well as the elements themselves are equal. Now obviously in a set the order doesn't matter, so the elements can be in any form, it can be written in any order, but the individual elements must be equal. And if they are not equal, I mean the elements are not equal but the number of elements are equal, then I say that the sets are equivalent but not equal. Fine. Then we talked about the subsets. Okay, a set is called subset of another set if all the elements of that set are also in the other set. So it is pretty much like one set is contained inside the other set. And then we talked about the different types of sets, different types of subsets, that is proper subset, improper subset, and so on. Then we talked about power sets. Power sets are nothing but the collection of all the subsets of a set, and also we discussed that given there are n number of elements in a set, there will be 2 to the power n number of subsets of that set. Next, we talked about subset of real numbers and intervals. Obviously any subset of real number can be represented in the form of intervals, and we just learned that there are 4 ways of representing an interval, or rather there are 4 different kinds of interval: closed interval, open interval, semi-open, semi-closed, like that. And then finally we discussed universal set. Now universal set is what? It is the superset of all the sets present in a particular problem. So for any given problem, obviously we can consider the superset to be any infinite set, no problem. We can consider the set of natural number, we can consider the set of real number, but definitely whenever I am talking about universal set, it has to be the minimal set. It has to be that minimal set which can be considered as the superset of all the set. So that is the idea. Now as we move on, let us first know what are the topics that we are going to cover in this class. So the first one that we are going to cover is Venn diagram. This is something which you already know, I believe. And then we are going to talk about operations on set. This is also something you know. And third one, we are going to talk about cardinality problems. So let us begin with Venn diagram. Now basically you already have some idea of Venn diagram. What is actually a Venn diagram? It is a pictorial representation of a set. So you can consider this as the third way of representing a set. The first 2 way being roster form and set builder form, and Venn diagram is the third way of representing a set pictorially. Now obviously there is no hard and fast rule that we have to always make use of circles to represent a set. Any closed shape, any closed geometrical shape can be used to represent a set, but it has become a convention to for circles to be used, but it is no hard and fast rule that you have to use circle. So that is obvious. And also another convention is that any universal set is to be represented using rectangles or square, but again this is a convention, this is not any hard and fast rule. You can make use of any other geometric shape you want, just to differentiate it. The square rectangle thing is just to differentiate a universal set from a normal set. That's it. So now let us move into the operations. So we already know some of the basic operations which can be used on a set, and we are going to work with those same operations, nothing new. The first one being union of two sets. What is the meaning of union of two sets? If there are two sets and I am taking union, it means I am collecting all the elements of both the set together at one place, obviously not repeating the common elements. So that is called union. So that means if I pick up an element from the union set, then that element belongs either in set A or in set B, right? Then A intersection B. A intersection B, obviously intersection means it is a common part. So obviously if there are two sets, whatever is the common element between the two sets, that is called the intersection of the sets. And obviously if you pick up any element from the intersection, that means that element belongs to both in the set A and B as well. Then complement. Complement means obviously complement. Complement means something which is not there. So definitely when I'm taking a set and I'm finding its complement, it means anything but the set, anything outside the set. So for finding a complement, we must have a universal set, and there must be a set inside the universal set. And when I'm taking complement of a set, it means the portion of the set which is outside and in between the universal set. That is anything which doesn't belong to the set but belongs to the universal set, right? And then the last one is difference. Difference means if I have two sets A and B and I am saying A minus B, it means the elements of the set A which is only in A but not in B. So therefore X belongs to A minus B. That means that X is only in A but X does not belongs to B. Fine. So that's exactly what the four operations are, and we are going to deal with these operations a little bit more elaborately. So let us take the first one, that is union. So union is also called join, and it is pretty obvious why it is called join, because you are joining the two sets together. That is how the name has come. Now we already have understood what union means, so let us now talk about the property. From the Venn diagram you can see exactly what union means. The shaded portion that you see, that shaded portion denotes the A union B operation, that where this A union B operation lies. Now let us discuss the properties. The first one, A union B is equals to B union A. So union operation is commutative, so it doesn't matter from which side you are taking the operation, you are going to get the same result. Next, A union B union C in bracket is equals to A union B in bracket union C. So this is called associative property. Associative property means if there are more than two sets in operation and you are taking union of all these sets, then it doesn't matter which two sets you are going to take operation first, you are always going to get the same result. Then the next one is A union A is equals to A. This is pretty trivial for us to understand. If you are taking union with the set itself, you are going to get back the set itself. This is called the idempotent law. Now those who have computer science, or those who have studied computer science and in class 9, 10, and if you have done Boolean algebra, you have learned this property, idempotent property, there itself. So it is following from there, no difference in that. Then the next one is A union null set is obviously A. It is pretty easy for us to see because null set has nothing in it, so you are taking union with it means you are getting back the same thing. Then A union, the universal set, is the universal set. Obviously yes, because universal set contains everything, so you are taking union with that means you are going to get back the universal set itself. Then if B subset A, then A union B is equals to A. Again, pretty obvious, B is already inside A, so when you are taking union with A, you are going to get back A. Then let us talk about the next operation, intersection. Intersection is also called meet. Now obviously yes, why it is called meet? Because this is the portion where the two sets meet. That is why it is given such name. So let us talk about its operations, I mean the properties. The first one is obvious, A intersection B is equals to B intersection A. It is commutative. Then obviously it is associative. Then it is idempotent, so all these three properties are same both for union and intersection. Then A intersection phi is phi. Well, pretty obvious again. Phi has nothing in it, so there can't be anything common with phi, so therefore its answer is also going to be phi. A intersection, the universal set is A. Again, pretty easy for us to understand why, because the universal set contains everything, so the set A is completely common to the whole universal set, so therefore you get back the whole set A. And the next one, if A intersection B is equals to 5, that means there are two sets A and B and their intersection is a null set. That means they are called a disjoint set. Disjoint means they don't have anything common. Then if B is subset of A, then A intersection B is equals to B. Again, pretty obvious. B is completely inside A, and that means what? B is completely common to both A and B. So therefore A intersection B will be B. Now the next one is distributive law. Now distributive law is, it is a combination of both union and intersection. So A union B intersection C is equals to A union B intersection A union C. So here what is happening, the union operation is getting distributed over intersection. And similarly the next one, A intersection B union C, that is equals to A intersection B union A intersection C. Here the intersection operation is getting distributed over union. Fine. Next, complement. Now complement, obviously complement means that if I have a set A, it is anything outside the set A, so that is called complement. So now the first operation or first property, A complement whole complement is A. It is pretty obvious. If you consider A complement as some set B, and if you are taking complement of that, so that means what? It is anything but that set B. But anything but that set B means it is, you are coming back to A. So therefore that's how it is. Next, universal set complement is null set. Pretty obvious, because universal set, the idea of universal set is that it has got everything in it. So if you are taking complement of that, that means there is nothing. So therefore nothing means it is null set. Again, complement of a null set is universal set. Obviously you are taking complement of nothing, so that gives you everything. Next, now complement, union, intersection, they combinedly they are having properties. They are called as the De Morgan's law, and the first one is A union B complement is equals to A complement intersection B complement. So union changes into intersection and the sets become complement. So this is the first one, and obviously the second one is A intersection B complement is equals to A complement union B complement. So these are the De Morgan's law. Now obviously these are all there in Boolean algebra if you have done before. So it is easy for you to understand this or correlate this with your Boolean algebra, because set theory, Boolean algebra, they are just flip side of a coin with different notations and different different interface, you can say, but the whole idea of set theory and Boolean algebra, they are almost same. Next, difference. Now difference is an operation which is a little bit different from all the other operations that we have done so far. Now the first one, A minus B, that is the operation A minus B is equals to A intersection B complement. Now A intersection B complement, let us first understand how it happens actually. What is B complement? B complement means leaving the set B anything else. So you can understand this whole thing is our B complement. This whole thing is our B complement, right? It is anything but the set B. Now if you are taking intersection with A, what you are left with? You are obviously left with this shaded portion. So that is how A minus B is defined. So A minus B is equals to A intersection B complement. Next, A minus A is equals to phi. Obviously if you are subtracting the set from itself, you are left with nothing actually. So it is pretty obvious. A minus phi is equals to A. If you are subtracting nothing from a set, you are left with the set. Then A complement is equals to universal set minus A. Pretty easy for us to see. Why? Because if I subtract the set A out of the universal set, then whatever is left is actually the A complement. And then A minus B is not equals to B minus A. So this is very important for us to see that difference operation is not commutative. And why so? Because you see, when I am talking about A minus B means this portion. This portion is A minus B. And B minus A is this portion. So obviously both the sets are not the same set, they are different sets. And thus A minus B is not equals to B minus A. And for the same reason, you can also check that it doesn't hold associativity as well. So A minus B minus C with bracket over B minus C is definitely not equals to A minus B bracket minus C. So these are the basic properties of the operations, different operations on set. Now let us understand this by solving some problems. Now obviously the first problem, it is given if A is equals to 1, 2, 3, 4, 5, 6 and B is 2, 4, 6, 8, then find all these different operations. So let us start with the first one, A union B. Now obviously what is A union B? Combining both the sets together without repeating the common elements. So A union B is exactly this. I hope it is easy for you to understand. Then A intersection B, obviously the common elements, and we can see 2, 4, 6 is common, so that is the answer. Then A minus B. A minus B means the elements which are only in A but not in B. So leaving the common elements out, we just think of all those elements which is only in A, and that is 1, 3, 5. Next, B minus A, again the elements which are present in B but not in A, and there is only one element, that is 8, and so is the answer. Fine. Next, example number 2. If universal set is given 1, 2, 3, 4, 5, 6, 7, 8, A is given 1, 2, 3, 5, 6, B is given 2, 3, 4, 7, 8, I have to find the following. So let us start off with the first one. A intersection B, well, easy for us to see. The common element is 2 and 3, so that is my answer. Next, A minus B. A minus B, yet again I have to find all those elements which are not in B but in A, and so that is 1, 5 and 6. Now the third one, I have to find A complement intersection B complement. So A complement, let us first find what is A complement. Now how to find A complement? Now A complement, as we have seen in the property, it is the universal set minus A. So that means we have to find all those elements in universal set which are not in A. So we can see that 4, 7 and 8, these are the three elements which are not in A but in universal set. So that is your A complement. Similarly, B complement is exactly what you have to do for B as well. Not in B but in universal set. And then you take A complement intersection B complement. So you can see there is no common element between A complement and B complement, and hence their intersection is null. Next, A complement union B complement. Now A complement is 4, 7, 8, which we have already found out, and B is given 2, 3, 4, 7, 8. So therefore I can say that A complement union B complement A complement union B is 2, 3, 4, 7, 8. That is exactly B itself. Next, on the real axis, if A is semi-closed, semi-open rather, minus 1, 1, and B is closed 0, 4, then find the following. Now obviously this is something you have done previously. You already have done this previously, but you never used the interval notation. You have used the less than greater than notation but not the interval notation. So if you want, you can always just convert these numbers into interval notation and you can do it. So just for your understanding, what is A? Let me just write. A is minus 1 less equals to x less 1. This is actually A. And what is B? B is 0 less equals to x less equals to 4. So now if you have understood that these are the sets, then you can definitely draw a number line and do it the way you have done previously in your class 9, 10 or any other classes before. But I will be doing it directly. So let us understand how to do it directly. Fine. So now let us start off with the first one. The first one is A complement. So what is A complement? See, A complement means anything which is not in A. Now obviously all these intervals, they are the subset of real numbers. So here the universal set is my real number set. So R is to be considered as the real number set. Now again, the set of real number is nothing but it is from minus infinity to infinity, right? This is exactly what the set looks like. That means if I draw the number line, this side it is minus infinity, this side it is infinity, right? Now minus 1 to 1 is exactly where? Minus 1 to 1, for example, here say this is minus 1 and here this is 1. Just don't mind my drawing. Say this is 1. Let me just draw it once again. Fine. Now minus 1 is included but minus 1 is not included, right? So if I want to take the complement of this, when I am taking the complement, it means I have to take from minus infinity, I have to take this whole thing, but just up to minus 1, not taking minus 1, right? And again on this side, I have to consider 1 and I have to take everything this side. I have to consider 1 and I have to take everything this side. So that means the complement is going to be minus infinity to minus 1 open and closed 1 to infinity. I hope this idea is clear. Let us take another problem and let us understand. So now this is your answer anyway, so just do it yourself once, you will be able to understand. Next, let us take the second one. Second one is A union B. So you are taking union of A and B. Second one is B complement. So once again, B complement, let us just draw it. So I have the number line. Here I have 0. Here I have 4. So now 0 and 4, they are both considered actually here because they are closed sets. Now if I want to take its complement, that means I have to take this whole thing, but just before 0, means I have to leave 0 out, and again on this side I have to leave 4 and I have to take everything on this side. I think this idea is pretty clear how we are taking the complement. So if this is clear, now we understand how we are doing the union. In case of union, let us understand this once again. Let us draw the number line. Say this is our number line. First, let us draw minus 1, 2. Here there is minus 1. Here there is 0. Here there is 1. And here there is 4. So minus 1 to 2, 1. This is set A. And 0 to 4, this is our set B. Now when I am taking union, I must take everything in between. So therefore I can see that my union is exactly this one, minus 1 to 4. Starting from minus 1 including minus 1 to 4 including 4. I hope it is pretty easy for us to see. If you don't understand, go through it once more. I am pretty sure you will be able to understand. Next, A intersection B. A intersection B means the same thing. It is the common thing. So I just deleted it. Sorry. So let me just draw it once more. A intersection B, that is again minus 1, 0, 1 and 4. So set A, let me use a different color, that will be easy for us to understand. Set A is minus 1 to 1, taking minus 1 and leaving 1. And what is set B? Oh God, I deleted it. Okay, just bear with me. I am technologically not that sound, so I have to just understand how everything works here. Okay, so this is your minus 1. Here this is 1. So I think now this is better for us to work with. Right. And then let me take a different color. Okay. So here there is 0 and here there is 4. Okay. And this is my set B. Now obviously you can see what is the common portion here. The common portion being this much. This is our common portion, right? So it is closed 0, open 1. So that is my common portion in the two sets, and therefore I can say my A intersection B is minus 1 to 1, intersection 0 to 4, that is closed 0, open 1. Fine. Next, so I am not explaining it anymore. You just go through it once more and try doing it by drawing the number line yourself. I am pretty sure you'll be able to understand. So minus A minus B, that means something which is only in A, not in B. So I can see the only portion which is in A but not in B is from -1 to open 0. So that is it. And again B minus A will be closed 1 to closed 4. Fine. So just give it a try yourself. Try doing it all by yourself. I'm pretty sure you'll be able to understand. Next, let us move to next problem. Problem number 4. Problem number 4. From the adjoining Venn diagram, write the following. Now, here the sets are not given in the roster form or set builder form. You are given directly the Venn diagram. Now, from here, you have to write all this. Now, obviously, first understand what is set A. Here, set A is 2, 4, 3, 0, 8. So, this makes set A. So anything which is outside this 5 values, that is in your complement. So therefore A complement will be 1, 5, 6, 7, 9. That's it. Then B complement, once again let us understand what is B. B is 3, 0, 8, 5, 6. So anything outside these 5 numbers will be complement. So B complement is 1, 2, 4, 7, 9. Right? Now A intersection B complement. So now what is A intersection B? A intersection B is 3, 0, 8, and leaving these 3 numbers, anything else is in its complement. So therefore A intersection B is 0, 3, 8, and hence the complement is 1, 2, 4, 5, 6, 7, 9. Right? Simple and easy for us to understand. Next, problem number 5. What is represented by the shaded region in each of the following Venn diagram? Now, this is something which we have to understand. See, the first one, this portion means A minus B, as we have already discussed. This portion means B minus A. This is also something we have discussed. So when they are combined together, that means what? I am taking union of the two. So therefore the first answer is going to be A minus B union B minus A. Right? I think it is clear. Next, in the second problem, I have the whole set of A. I have this whole set of A, and together with it I have B intersection C, right? So therefore I can say this is A union B intersection C. The whole set of A and the intersection of B and C together combined. So I can say this is A union B intersection C, right? Now obviously go through it, you will be able to understand. Next, now we come to something called the cardinality properties. This is our third topic to be discussed. Now cardinality properties are something which I think you have idea, but still let us discuss one by one. The first one, the number of elements in A union B, that is equals to number of elements in A plus number of elements in B minus number of elements in A intersection B. Right? Cardinality means number of elements. I hope you remember that. Next, if A and B are disjoint, then number of elements in A union B is exactly number of elements in A plus number of elements in B. That is easy for us to understand. Why? Because A intersection B is empty, and so there is no element there. Next, number of elements in A can be written as number of elements in A minus B plus number of elements in A intersection B. And finally, if there are 3 sets, then number of elements in A union B union C is equals to number of elements in A plus B plus C, then minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. Now let us prove this, how it happens. Let us prove this, then we will be able to have a clear picture of this. So let us take the first one. That is n of A union B equals to n of A plus n of B minus n of A intersection B. So we are trying to prove this, how it happens. So now let us understand what is A union B. A union B is this set, right? And then how can I represent this? I can represent it like set A, all the elements in set A, plus all the elements in set B. Now in this addition, I am adding this common portion twice. You see, in both the cases I am adding the common portion twice. So adding the common portion twice doesn't actually give me the correct number. So what I need to do, I need to subtract this out. So if I subtract the common portion out once, then I get exact number of elements in the union. So just give it a thought. You will be able to understand. Right? Next, let us take n of A is equals to n of A minus B plus n of A intersection B. So once again, let us see what is n of A. N of A means this on all the elements inside the set A, and this can be written as all the elements in A minus B. So this is exactly your A minus B. This is my A minus B, right? All those elements which are only in A but not in B. And then if I add the A intersection B, this is obviously my A intersection B, right? So pretty clear for us to understand why it happens. Now let us try doing the biggest one, that is this one. Let us understand. By now obviously you have understood how it's happening, so let us still do it. So A union B union C, what does that mean? It is combination of all the elements present in 3 sets. Now this time you are having 3 sets. So now how we can break this down? So see, we can break this down as all the elements present in A plus all the elements present in B plus all the elements present in C. Now in this addition, what I have done, if you notice, I have added A intersection B, sorry, don't mind the color, okay. I have added A intersection B and A intersection C once, A intersection B twice, then also B intersection C, then B intersection C twice and A intersection C twice. So all the intersections I am adding twice, if you can see. When I am adding each and every single set once, I am actually adding their intersection twice. So I must subtract the intersection once. So therefore I must subtract A intersection B once, then I must subtract B intersection C once. Here I have subtracted A intersection C, and finally I must subtract B intersection C. So I must subtract all these 3 intersection once. Now while doing so, see what I have done. This common portion, that is the A intersection B intersection C, I added it 3 times. And again I subtracted it 3 times. I subtracted this common portion 3 times. So the common portion is not included at all. So now what I need to do? I need to add this common portion once. That's it. That is pretty much the idea. So if you break it down, it is easy for you to understand. And for the matter of fact, you just have to remember the formula. You need not understand how it comes, but it always helps if you know how it comes. Okay. Now let us move to problems. We will be solving 2 or 3 problems and we will be done. So let us take the first problem according to the numbering. This is the 6th problem of this class. So the first one is given. Number of elements in A is 20, number of elements in B is 18, and number of elements in the intersection is 5. Then you have to calculate all these things. So the first one is A union B. So A union B, we already have the formula, so put it in the formula. So it is very easy for us to see what happens. So 20 plus 18 minus 5, that is 33. Fine. Next, A minus B. Now obviously we already have the formula. N of A is equals to N of A, that is equals to N of A minus B plus N of A intersection B. Fine. So from there I can write A minus B is equals to N of A minus N of A intersection B. So that's exactly what I have written. Then the third one, N of B minus A, the same way, NB minus N of A intersection B, and that is 18 minus 5, that is 13. Right? Simple, clear, easy to understand. Just remember the different formulas, you will be able to solve. Next, N of universal set is equals to 48. N of A complement union B complement is 36. I have to find N of A intersection B. Now, first we need to understand or remember the De Morgan's law. What was De Morgan's law? We know A intersection B complement is equals to A complement union B complement, right? So obviously, what is N of A intersection union B intersection? Now I can write it as A intersection B complement. That is exactly 36, right? Now what is complement? I know it is the universal set minus the set. So therefore N of A intersection B, that can be written as N of the universal set minus its complement. So that is my answer. If you remember this somewhere, that A complement is equals to this. A complement is the universal set minus the set. So that's exactly the property I have used. Example number 8. Now this is a text problem. In a group of 400 people, 250 can speak Hindi, 200 can speak English. How many can speak both Hindi and English? So first what we do, we first name the sets. So let us consider capital H to represent the set of people speaking Hindi, and capital E representing the set of people speaking English. Now always remember, whenever there is a word problem, now you people are in class 11, pseudo class 11 if I can say, because you are still to give your class 10 exams. So you have to write statements. You can't do away with that, because you are now grown up, you are in higher secondary, no more in high school, but you are now in higher secondary. So a problem without proper statement is absolutely meaningless. Without statements, your problem is as good as incorrect. So therefore, please ensure whenever you are solving the problems, do write your statements properly. Then once we have represented H and E as the sets, now let us write what are the things given. So the first thing is given that the number of elements in the set H is 250, number of elements in the set E is 200, and it is given that in a group of 400 people, so we can assume that all those 400 people either speaks English or speaks Hindi. So therefore that is the union. Therefore what I need to find, I need to find how many of them speak both Hindi and English. So therefore I need to find the intersection. So now put all the values and calculate, you get your answer. So 400 is equals to 250 plus 200 minus this, and hence the intersection is 50. So there are 50 people who can actually speak both, and that is your answer, right? Just go on, give it a good look, try solve or try going through the problems in your example as well if you have a book, or these are self-sufficient for you to understand anyway. Next problem, and I think this is the last one. Okay, a huge problem. Let us first read it out. In a survey of 100 students regarding watching TV, it was found that 28 watch action movies, 30 watch comedy serials, 42 watch news channels, 8 watch action movies and comedy serial, 10 watch action movies and news channel, 5 watch comedy serial and news channels, and 3 watch all the 3 programs. Draw a Venn diagram to illustrate the information and find how many watch news channels only and how many do not watch any of the 3 programs. Okay, so before I can draw the Venn diagram, I have to name the sets. So let the news channel set be the number of students only watching news channel can be named as N. For the action movies, let it be A, and for the comedy serials, let it be C. Fine. So now we have to understand what are the things given out of 100 students. Now always remember this. This 100 students does not represent the union. Why they does not represent the union? Because in the question it is given how many do not watch. How many do not watch. This do not watch is given. So the do not watch means there are certain students who are not inside the union. Because if somebody is not watching, that means what? They are not inside the sets, they are outside the set. So therefore, this 100 represents the universal set but not the union. Remember this. So therefore, we have to draw the Venn diagram understanding certain thing, that the universal set contains 100 students. Then 28 was found to watch action movies, so set A contains 28 students. Then 30 watch comedy serials, set C contains 30 students, and set N contains 42 students. Now this is something we understood at the beginning. Then 8 watch action movies and comedy serials, so that means they are in the intersection. 10 watch action movies and news channels, so these are all intersections. So once we can draw this basic structure, this is the basic structure, then we can definitely put all the values in the intersection. So let us see how to do it. So this is exactly how you should do it. See, the universal set contains 100 students, so that is written there. So this is exactly what we have done. This is 100 students. Set A contains 28 students, so that is written there. Set C contains 30 students. Set N contains 42 students. And then all the intersection values are written inside. Okay, that's how you represent this whole data inside a Venn diagram. Clear? Now we have to solve the problem. How many watch news channel only? Now let us go into the problem first. Now you see how to find which is the first part we need to find out. How many watch news channel only? So they do not watch the other two but only this. So we are talking about this portion exactly, where they watch only news channel. So how to find this? We have to subtract the intersection portions, and also while in subtracting the intersection portion, I will be subtracting this common portion twice. So I have to add it back once again. So it is exactly something like this. From the set of N, I am subtracting the intersection portions, but while I am subtracting the intersection portion, I am subtracting the common portion twice, so I have to add it back. And if we do so, this is my answer. Right? I hope this is clear. And in the second case, I need to find how many do not watch any of the three program. Now this 30 students, as you see, they watch only news channel. So the good thing is they will grow up and they will be becoming the good person, the good citizens in the country, but otherwise they will be boring anyway. And then in the second case, I need to first find out the union. I need to first find out how many of them watch any of the three. So then I will be subtracting that from the total number of students. Then I will be getting how many do not watch any of them at all. So we already have the formula for finding the union, and all the values are given. So let us put all the values and find out. So after putting all the values together, we find that the number of students who watch any of the three is 80. So now if I subtract this from the total number of students, I get the number of students who do not watch any of the three. So therefore, the number of students who do not watch any of the three, that is 20. And I can tell you that these 20 of them are actually doing TikTok. Very bad. Don't do it. Anyway, so this is our class. Thank you so much. I hope you have understood. If you haven't, you can always come up with your doubts for clarification. But before you come up with your doubt, it is always good that you discuss among yourselves, so that if one has understood, then that one person can clear your doubt. And it is always good to clear your doubts among yourself first. Then if you have doubts with the problems, then definitely you can always come up with your doubts. And otherwise, go through this once more, once, twice, as many times as you want, so that you get the clear picture of the whole idea. A little bit, I shouldn't say it is difficult, but it is a little bit tricky thing to keep in your mind. And as the slowly it kicks into your mind that how class 11 is going to be from here on. So just give it a good look. I am pretty sure you will be able to understand. So thank you once again.